Dear friends, welcome to the next session for software engineering and designing concepts. So in today's session, we will be looking at another behavior oriented diagram which is known as the sequence diagram. So let us get started. So sequence diagram simply depicts interaction between objects in a sequential order, that is, the order in which these interactions take place. We can also use the terms event diagrams or event scenarios to refer to a sequence diagram. They also describe how and in what order the objects in a system function. These diagrams are widely used by businessmen and software developers to document and understand requirements for new and existing system. Most importantly, we have to understand that the sequence diagram generally represents the objects and its associated interactions within the system. Up till now, what we were discussing was a bird's eye view of the system along with the various control processes that the system undergoes or the various classes it interacts. In this particular diagram, we will be looking at the different types of objects which are actually taking part in the system for any type of activity to be carried on. So the main purpose of sequence diagram can be categorized into these following points. First of all, it models high-level interaction between active objects in a system, and it also models the interaction between object instances within a collaboration that realizes a use case. It also models the interaction between objects within collaboration which realizes an operation, and either model generic interactions which shows all possible paths through the interaction, or specific instances of an interaction which show just one path through the interaction. So we have to understand that whenever we are drawing a sequence diagram can only be collaborated or can be represented for one particular use case. We cannot represent the sequence diagram for multiple use cases as such. So whenever we are drawing a sequence diagram, it is representing the scenario for just one use case. That use case may be, let us say, pay, let us say issue book, or return book, etc. However, it is not feasible and not practical to represent both of them in a single sequence diagram. So we have to extremely be important while representing such a scenario. Then next we will talk about the various notations or symbols or elements which are used in the sequence diagram. So a sequence diagram contains the objects of a system and their lifeline bar and the messages passing between them. So most importantly, we have to understand that each of the object has a lifeline associated with it, and this lifeline is represented along with the activation time in a sequence diagram for each of the objects while the interaction is still taking place. The first element in a sequence diagram is the object, and objects appear at the top portion of the sequence diagram, and it is shown in the form of a rectangle box. So this rectangle box will be representing the object, where within the box we have to represent using a sequence diagram notation, which is the colon. This colon is preceded, or the object name is basically preceded with this colon, and the class name from which the object is instantiated. The whole string is underlined and appears in a rectangle box. Also, we may use only class name or only the instance name. So this is how we will represent a particular object in a particular class. So objects which are created at the time of execution of use case are involved in message passing appears in the diagram at the point of their creation. So we have to understand which type of objects are taking part in the entire interaction and accordingly name it or accordingly represent it. The next element in a sequence diagram is one of the essential entity, which is known as the actor, and an actor in a UML diagram is common in all types of representation where it is represented using a stickman, and it is a type of role where it interacts with the system and its objects. We have to know that it is important that the actor is always outside the scope of the system we aim to model using the UML diagram. It might be either a use case, then also the actor stays out of the system boundary. If we are talking about a sequence diagram, then also the actor will stay out of the system boundary or the entire system, and from the outside only the user will be able to interact. The next is the lifeline bar. So this lifeline is a named element which depicts an individual participant in a sequence diagram, which is basically the object or the class. So basically each instance here in a sequence diagram is represented using a lifeline, and these lifeline elements are located at the top in a sequence diagram. The standard in UML for naming a lifeline follows the format, which is instance name colon class name. So basically we represent or display a lifeline in a rectangle called head, which we have already discussed, that is the object representation, and we will be representing it using this dashed line. So this dashed line is the entire lifeline bar of this particular instance of the class. Now we will talk about the activations. Now we have already talked about object and its lifelines. So whenever we are representing a thin solid rectangle, it represents the period during which the element is performing an operation. So whenever we see something like this, this means that it is performing any type of operations or it is an inactive mode. So the top and the bottom of the rectangle are aligned with the initiation and the completion time respectively. However, this particular amount of time, the object will remain active for its interactions. The next important element in a sequence diagram is the message. So communication between objects is depicted using these messages. So these are primarily the different types of messages: synchronous messages, asynchronous, self message, reply message, participant creation messages, participant deletion messages. So all these type of messages will be associated while establishing communication between various objects. They appear in sequential order on the lifeline. We have to make sure that whenever we are writing any type of messages, we are associating a sequence number with the message so that we identify which message is taking after which other messages. So lifelines and messages form the core of a sequence diagram, and they can be classified into, as already mentioned, synchronous, asynchronous, self, reply, or different types of participant creation or deletion messages. So this is a typical example of the sequence diagram, and we can also associate, since the actor is not here, we can always represent this actor here, and this actor will be active throughout the interactions. So this is something similar to the library boundary, but this actor will remain out of the library boundary. So whenever an actor is going to use this particular sequence diagram, we have to first identify that what type of use case we are going to represent using this sequence diagram. As already mentioned in the previous slides, that we can represent a sequence diagram only for one particular use case at one particular time. Not multiple use cases can be represented using the same sequence diagram, otherwise it will become very chaotic and ambiguous to understand what is followed by what. So here in this example, we are taking the scenario of renew a book use case. So this is just a single use case that we are representing using this use case, using this sequence diagram. So the user will be raising a request. Let us say that the user is requesting for renewal. Request for renewal. So this message is number 1 and it goes to the library boundary, and the library boundary sends the message, the second message, to the library book renewal controller. So once the library book renewal controller object receives this message in its vicinity or in its jurisdiction, it will display the user what are the books that he has already borrowed from the library. So once the user gets the number of books that are being borrowed by him, he can select the books which needs to be renewed. In between there is another message which is find member borrowing. So we can include or we might not include here depending on our design strategy. So if the library book renewal controller itself is basically is having the database of all the users that are using the library, it does not need to send this message at all. However, if it feels that the library book renewal controller feels that he has to check in the library member database and this is handled by a separate object, then he needs to send this request across to the library member object. So once this library member object receives this, it will be then sending a reply back. We have not included this in this example. That is why we are simply showing the display borrowing status of the library member from the library book renewal controller itself. After that, the user will be selecting the books he needs to renew, and then the selected book is then sent to the library book register, and it will be this library book register object will then send a find option to the book object or the book database which is already there. So if the book can be renewed, it will be confirming a reply that this book can be renewed, and in return the library book renewal controller will confirm the reply back to the user. So after this we will follow this sequence 7 and 8. So however, if the book object in its jurisdiction or in its functionality could not find options for renewal of that selected book, then it will be sending an apology to the user back again through the various interfaces that the message has come across, and it will ultimately update to its database that book was not renewed. So this is the scenario if it is rejecting the renewal of the book. However, as already said, as number 7 message says that if it could renew the book, or if it has the capacity of renewing that book, because we see that some of the books after you have requested for a renewal twice or thrice, now it cannot be renewed back to the same person because he has already exhausted his limit of number of renewals of a particular book. So after 3 or 4 times, the library will definitely refuse the or reject the renewal of the book. However, if they feel that they could still the book can still be renewed, so it will send a confirmatory message back to the user, and it will also update the member which is borrowing that particular book, and will be updating the renewal date as well, that by when he has to return the book. So this library member is the object in that particular library member database, and it will be holding the details of the user, where against that particular user, let's say the user ABC has taken this book and it is renewed, and he has to return by, let's say, 12/12/2020. So this thing will be updated in the member database by the member object. So this is how we can represent both a positive scenario this is a negative scenario as well as a positive scenario. But this scenario is valid only for one particular use case. We cannot represent multiple use cases in the same diagram. So now some of the common mistakes which we do while designing a sequence diagram is, first of all, adding too much of detail. So we do not need to add too much of detail, just the minimum number of minimum information which is required in order to represent that scenario. The next is obsolete and out of date sequence diagrams which are irrelevant when compared to interfaces, actual architectures of the system. Sometimes we feel that we simply have to draw a scenario for it, and we go ahead with drawing that scenario, but in reality that scenario does not match with the actual reality. So in that case, the sequence diagram will not work. So do not forget to replace them or modify them whenever you feel that there is a change of interfaces. So leaving no blank space between the use case text and the message arrow, which makes it difficult for anyone to read the diagram. So that is self-explanatory. And not considering the origins of message arrows carefully. So if we look at the previous diagram also, we have to identify from where the message has been originated. So talking about message origination, we have to understand that we simply cannot go ahead with any type of arrow drawn from any point. We have to understand that we have a user, and from here the message has been originated, and we have to respond it back to the user. So this is done by the software itself. Up till this part, this is done by the software itself. However, this include a manual process where the librarian probably will be informing to the user about the unavailability or availability of renewal option, and this will entirely be the software based system. So we have to carefully identify which things we need to represent and which things are not necessary for representing in order to avoid making our system clumsy. So that is all for today. Thank you.